Question 8. We're going to insert a graph page, and we'll type in the function negative x multiplied by, open brackets, x plus 5, close brackets, all squared, and then press enter. So if we just rescale this, I'm going to go over the y-axis. I've got a whole load of stuff there, so what I could do is I can move the label out of the way. And when it comes up with tab, if I just press the tab key, I can get the axes. I'm going to grab hold of the axes and then hold down the shift key, and that allows me just to stretch the y-axis on its own, and then I let go. So I need to find out where it cuts the x-axis. Well, it obviously cuts at 0, and hopefully your knowledge tells you that it cuts at -5 twice. There are 3 intersection points here, 2 of them happen to be the same. Now we're looking for the exact coordinates of the maximum turning point up there. So if I do menu, analyze graph maximum, and go to the left, and then go to the right, it would appear as if this is -5/3 and a y value of 18.5. If you wanted to check if you were being really precise there, I mean -1.67, if I go over it, press the plus key a few times, it certainly looks like 1 2/3 or -5/3. If I insert another page, Control Doc, and go to calculator, if I press var, I can use the function which I've defined, and if I type in just -5/3, so I'll do Control Divide to get a nice fraction template, -5/3, and then press enter, it gives me the exact value, and 500 divided by 27. If I wanted to force that to be a decimal, I could press Control Enter. I get 18.51, which agrees with the value which we see on show there. So obviously hinging around it being -5/3 in the first place, and you can do normal calculus algebra to establish that. And the point of inflection, a point of inflection is when the second derivative is equal to 0, so I need to do the second derivative of this graph. So if I just press tab, and then go to the templates menu, and choose the second derivative icon, I'm going to type in x for the variable, and for the function I'm going to type in var. Oops, what happened there? Let's press escape. Let's try that again. We'll type x. When we get there, we'll just type var. It doesn't like that, so we may have to type it manually. Press tab. Third time lucky. X. And we'll go into that space and we'll type f1, open brackets, x, and then press enter. So there's the graph of the second derivative. The 0 is where the inflection will be. And so what I can do is I can find out when that 0 is. I can do menu, analyze graph 0. I need to tell it it's the red function I'm interested in, and go to the left and go to the right. And it looks like -3 1/3 or -10/3. And the exact coordinates of the point of inflection will be directly above it. So what I can do is I can do menu, geometry, construction, and I'll do a perpendicular line. I'll go through that point perpendicular to the x-axis to find that intersection point there. Let's just put that point in, and then I'll press escape. Oop. I'll have to construct it again, it seems. I'll do menu, geometry, points and lines, point, put the intersection point there, press escape to take out of point mode, go over that point, press control menu, and pull up its coordinates. So it looks as if -10/3 and 9.26, but again it wants the exact, so I want to evaluate this function at -10/3. So if I just go back to there, change the -5 to be -10, and it looks as if that will be the y coordinate, the exact y coordinate of the point of inflection, if of course this -10/3 is the correct value. Well, if nothing else, you've got lots of decimals there to tell you that if any algebra you've done is on the right tracks. We're done.